Looks like we'll be right around 15 to 20 minutes for this, so sit back and enjoy.
Okay, thank you, Mike. So, as Mike said, we are going to be talking about 3D laser scanning capabilities at Pro Engineering. I am Shane Burkart. I am a Vice President and Principal Consultant. I've been with Pro Engineering for a little over 11 years now. So the reason we're talking about laser scanning is that I have a really good story that I'll tell you guys later as to how we found laser scanning by accident. So first I'm going to do just a quick brief overview and introduction of Pro Engineering. We're celebrating our 20 years of being in business next month. We are structural, mechanical, and electrical engineers with a focus in heavy industrial, chemical, and food processing industries. We also have safety and project management consulting expertise in-house. Oops, backing up. So here, quick overview of our structural, civil engineering design services. We can basically do anything structural related, whether it be small maintenance monorails up to large new buildings or building additions and modifications. We also have a expertise in stack and chimney, either design of new or repairs to existing, and condition assessments and repairs. So in our mechanical engineering, we can do piping, energy analysis, HVAC, machinery troubleshooting. We have lots of expertise in pulp and paper industry. So pretty much full service in mechanical engineering. Same with our electrical engineering design services, power distribution, control systems, hardware and panel design, and being able to put together construction packages and help with on-site assistance during installations. We have project management services in-house and safety consulting. We have a senior safety consultant. He comes to us with over 30 years of professional firefighting experience and in instruction. So doing OSHA evaluations and training compliance and determining if there are any safety hazards and stuff like that. We have in-house design services for BIM and drafting services, and under that falls our FARO 3D laser scanning, which is the meat and potato of today's presentation. So, why does Pearl Engineering have 3D laser scanning? In 2014, I was sent off to an aircraft hangar to measure up the facility with a tape measure, a disto, and a pad of paper. And they were unable to empty the hangar, and we only were able to access a few of the frames. And as you see here, there was a very large fan. And so I did my best to estimate the location of that fan and did the design. And as they went into construction, one of the drops for the fall protection locked out this fan and caused a very large and expensive rework over a weekend. And so when that was all said and done and everything was good on that, I thought to myself, how could we have prevented this? And that is when I discovered 3D laser scanning. And so for a while after that, we hired out the services and consulting for 3D laser scanning, and then eventually purchased it in-house. So in-house, we have two FARO Focus 3D. These are kind of the workhorse of our scanning operations. And so right now, I'm just going to do a quick, show a quick video for the introduction of this, because FARO does a much better job of it than I can in this kind of setting here. Normally, when I introduce this, I'm out in the field with people, so I get to show them the application as, you know, and talk through it as it's running. But this is the next best thing here for us.
FARO, the world's most trusted source for 3D measurement technology develops revolutionary portable measurement and imaging solutions. FARO's commitment extends well beyond product performance and constant innovation in order to build an ongoing relationship with our customers and help make their products' processes the best in the world. The FARO Laser Scanner Focus 3D is a high-speed three-dimensional laser scanner for the detailed measurement and documentation of large objects, spaces, and buildings. With a range of up to 120 meters, the Focus 3D creates photorealistic three-dimensional images of reality. Thanks to its intuitive control concept with a touchscreen display, it's as easy to operate as a digital camera. The rotating laser of the scanner touches, in the truest sense of the word, its surroundings. The laser beam is used to measure the distance to the object and, together with the device's rotation angle data, determines the coordinates in space. Several million of these 3D coordinates result in a complete three-dimensional impression of its surroundings. Color scans are produced with the help of the integrated digital camera. The scan data is saved on the internal SD card, making it very user-friendly to transfer the data to a computer. FARO's Scene software automatically combines individual scans with the aid of integrated sensors in the Focus 3D, such as dual-axis compensator, height sensor, and compass, to create a cohesive point cloud. Data acquisition by means of 3D laser scanning is faster and more reliable than conventional documentation methods. Whether for three-dimensional building documentation, monument preservation, or forensic crime scene documentation, thanks to its simple operation and compact design, the Laser Scanner Focus 3D is ideally suited for a variety of applications. At FARO, our focus is on simplifying our customers' work with tools like the laser scanner that empower them to obtain data more quickly, easily, and with less cost than ever before. Today, thousands of customers worldwide trust and work successfully with various FARO solutions, making FARO the world's most trusted source for 3D measurement technology. The FARO Laser Scanner Focus 3D. The world's smallest, lightest, and most affordable 3D laser scanning solution.
Okay, so like I said, we have two of those in-house, and those are our workhorse of our 3D scanners. We also have let's see here. Our FARO Freestyle 3D is a handheld scanner, and it is for more unique, kind of intricate, detailed measurements. So here we'll watch a little demonstration of that.
Industries such as construction, civil engineering, interior design, and BIM depend on reliable, fast, and accurate data. With conventional tools, very time-consuming measurements must be done. In many cases, an accurate measurement is not possible to achieve with traditional measurement tools. Until now, the documentation of objects in narrow spaces or with complex shapes have been inaccurate and unsatisfying. With FARO's Freestyle 3D, the scanning process is quick and extremely precise. The gathered digital data provides civil engineers, architects, and interior designers with detailed 3D point clouds and enables the accurate documentation of the desired area. This is a major step forward for any construction project and improves the planning process. The new FARO Freestyle 3D.
Okay, so with the little introductions that we just saw there from FARO for what our equipment actually is, when we go on site and we're starting to plan some of the considerations that we need to take in place is that laser scanning is line of sight, and any areas of specific interest we need to be made aware of and need to make sure that they're visible. Otherwise, it won't be captured. So this can include either maybe moving some equipment or partial removal of a wall panel, or cleaning up of debris that might be on a structure or around it, because it will just capture whatever it sees, as it says, the laser touches. So with this, the line of sight, it also creates some interesting artifacts that you may get from with it being line of sight. So when we are looking at the data, we need to use our engineering experience and expertise and marry that with how we know the technology works to know what we're looking at. Sometimes a wide flange beam may look like an hourglass in the scan, so we need to be able to look at that and say, well, I know I'm smarter than that it's not an hourglass shaped there. So just small things like that. So it's not just, send it out and it does everything automatically. There's still human interpretation in this. So the site conditions, we do need to have a solid surface free of, or mostly free of vibration, for it to be able to collect the data. It's rather precise as it's spinning and collecting these angular measurements. Highly reflective surfaces have caused issues in the past, and they can be overcome. It's just we need to be aware of them ahead of time so that we can, either turn the lights down or maybe put a spray or a cover or something on some of these highly reflective surfaces that can cause scatter of the data, or just be prepared that it's going to take additional post-processing time to clean that data up. And that's reflective in the cost of how we'll estimate a job. Limited movement of people or objects in the area. Once again, with it being line of sight, if there's something moving in front of it, it can prevent us from seeing what we need behind it, or it can just basically create a whole bunch of noise in the background. Once again, it's not the end of the world. We can definitely work while people are in the area and stuff. It just may require additional post-processing time and increase the overall project cost for that. So there's some things to think about as we are planning a laser scanning project. So once we have the project scanned, we come back to the office, and as they mentioned in the video, we run it through Scene, we put it all together. We also have FARO As-Built for Revit, which allows us to take and use the data from the point cloud a little bit more intelligently than just as a background to trace on top of. So what we can do with FARO As-Built is we can bring in measurements and locate walls and pipes and the skew and the slope of pipes and structural members. You can go through and try and take a stab at identifying what type of wide flange it is, something like that. So here I have a quick little few-second demo of showing how the piping feature works here. So as you can see, we're trying to utilize technology as much as we can to help be more efficient, more accurate, and be able to get designs out with fewer people, because we always have constraints and crunches to be able to fulfill these. Okay, at this point, Mike, do we have any questions that have come in? It looks like you're muted, Mike.
Right now, I do not see any questions, Shane. Does anybody have any questions on the FARO Freestyle or our handheld scanner?
Okay. Well, what I will do is I'll continue, and if questions pop in, please enter them into the Q&A portion, and we'll get them answered. So I will continue along here. So the point cloud data, there's multiple formats that point cloud data can be exported to. We at Pearl, we typically work within the Autodesk umbrella of suite of software. So the point cloud is natively accepted into Navisworks, Inventor, Revit, and AutoCAD. And Recap is the software that is kind of like the powerhouse of controlling what the point cloud, how it interacts with these softwares. So I'm going to do a quick demonstration, and I'm going to hop out of the PowerPoint here, and we will jump into Recap. And here we have a project that was in a boiler room of a school, and they had issues with corrosion. And so I came in and laser scanned it up and determined that what had happened is all of this was from chloride attack, because outside of this is exposed to the elements, and they heavily salted as it's a walkway into the school. And so what we were able to do with these laser scans is we were able to do a condition assessment, kind of figure out what we really have going wrong in there. And the condition assessment drawings, here we have what we were able to bring right into Autodesk Revit with the point cloud and start marrying this with AutoCAD, or CAD data here, and start measuring and laying out and annotating and performing a condition assessment documentation for this project.
Yeah, Shane, can you zoom in a little bit on some of those cut views?
Yes, I can. Let me find one that's interesting. So here we have, this is a cross section of the room. Here we see the boiler room that we were just in. We'll kick back over, and this is essentially the view that we're looking at right there with the piping along the wall. We'll go back to, and then we can see here we are outside. We have our floor slab. Here's our beams that were attacked by chlorides. And so we can take and quickly and easily slice through the data and just get spatial representation of where things are relative. Now, prior to doing laser scanning, it would be rather difficult to marry accurately the outside measurements to the inside measurements. With a point cloud data, it's easy to slice right through it and get the relationship to everything inside and outside. So in this case, we did the condition assessment and turn that over, and then they determined that, okay, we need to move forward with a repair plan. So with the exact same data, we went into a phase 2 and started designing the repair plan and the shoring design. So we were able to figure out where we could put shoring posts and shoring beams and have a relationship to all of the stuff that could be in the way, and document, okay, if we have an interference, does something need to be removed, or can we just move the column over? So all of this planning at this stage greatly reduces construction time and delays due to questions that come up that need the engineer to come back out on site to look at an interference. So this is one quick example of showing how the point cloud data can be used in multiple phases of a project's lifetime. Looking back into recap here, so here we're looking at the real views of the project. So it's kind of like a 360 image that is captured from the scanner. So we can click and go right into the 3D view of this project. And so now what we're looking at is an actual representation, 3D model of that space that's combined with all of the other scans that were taken for this project. So we can kind of go back and forth between the two to better understand what we need. We also have the ability to change how we're going to display this. So right now we're looking at it with the color that came through from the photos from the scanner, but we can come through and say we want to look at a gradation of elevations. This is good for looking at like a floor slope relief or something like that. We can have the intensities that come back. So this is the actual intensity levels mapped that from the phase shift of the laser itself. So this is another view that kind of helps. Sometimes things are a little hard to see in just the black and white. And then we have one last one of looking at normals. So from the view that you have, it shows a color gradation as to what degree off of 90 degrees are you that you're looking at this data. So with this, just basically showing we have a couple different ways to visualize the data that can help you interpret what you're looking at. We can also go through and assign these points to different regions and use those regions to kind of turn on and off equipment or walls or things like that to maybe work through a demolition phase and say, okay, in this phase, these boilers are going to be taken out. We could put them on a region and assign them to that so that when we're over back in Revit that we can have them not in the way of our view. So we have a lot of flexibility in how we can display the data once we have it.
And Shane, that's a good point too. That's one thing that we've used to do process mapping on assembly lines or work cells for manufacturing clients of ours. So that's another really good thing too.
Yeah, absolutely. So we have a lot of flexibility with how we display the data and how we use the data once we get it in. And so with that, I think we're going to jump back into the presentation here because we're so now I have my next few slides basically are some real world examples of things that I've done with the laser scanner over the last few years. Here we have a stack that was nearing the end of its life, and we flew out to do a condition assessment of it. Laser scanned it in a few hours and captured the geometry of the stack itself and the adjacent platforms so that we could design a new partial replacement of this stack and be able to tie it all in back to the existing structure. So on the left, you're seeing what we had from the raw point cloud data kind of mapped out with heights and stuff. And then on the right is the 3D model of the new stack that we ended up designing for that. Another stack exam and repair project. This was at a power plant up in the UP. We were able to, in a day, go up and travel up there, look at the stack, do the condition assessment. There was no drawings of the stack, so we were able to laser scan it, get the as-built configuration of it, where the stiffeners are and the ladders and platforms and ductwork. All of these things were rather difficult to do in the past. Measuring stiffeners, you were kind of doing it from platforms where accessible, or you're trying to climb on the ladder, hold onto the ladder, and use a tape measure to try and measure down to a stiffener or up to a stiffener. So with the laser scanner, we're able to more safely document these things and have greater accuracy. I've done a lot of roof evaluations with the scanner, so we can come in and from the ground get a map, a layout of what's being supported from the roof, whether it be material handling equipment or piping, ductwork, all that kind of stuff. Lay it out, document it, figure out the loads, and then do the engineering to determine capacities and stuff like that. Here we can see that you can take and get a cross section of a roof joist or a truss. That's helpful to, if we don't know what that joist is, to do reverse engineering and analysis on that.
Hey Shane, it does look like we have our first question.
Oh, awesome.
So can you clarify, can you assign regions in the point clouds? Can the point cloud regions or layers be carried over to Navisworks?
Ooh, that is a very good question. I would guess so. I know that in Revit, you can go and in the visibility graphics control and turn on and off the regions. And I have not done it in Navisworks, but if we get who it is, I can dig into that and get back to them. So I will definitely dig into that. I suspect that since it's part of the Autodesk umbrella, that there is a way to do the visibility graphics and control of that. So I just need to confirm that.
Excellent. Thank you, Shane.
Okay. Moving right along here. So fall protection. I've done a lot of laser scanning for fall protection, and where it works well is for pre-engineered metal buildings. The frames are difficult to measure and document because the top slopes to create the roof slope, and then the bottom of the frame itself will slope. And even with angle finders and stuff, it's hard to document and accurately represent that. So what we can do is we can come in and with some handful of laser scans, get the frame general arrangement, get where the stiffeners are, any of the brace locations and stuff like that, and then strategically go up and do ultrasonic thickness readings at key points along the frame to be able to reverse engineering and do analysis on that frame to determine capacity if the existing building drawings aren't available. Even if the existing structural drawings are available, there's still value in laser scanning because we can then take the as-built configuration with all of the piping, conduit, ductwork, and all of that, and marry that with the structural data that we have, and that's kind of like the holy grail of being able to help in the engineering process, is having the original drawings and a laser scan. Rooftop HVAC and other equipment, being able to accurately show conduit locations and piping relative to the structure, roof penetrations, all of that is quickly and easily documented with use of laser scanning. This here is one of the more unique projects that I did with the laser scanner. This is actually the bottom side of a bridge crossing a shallow portion of the Wisconsin River. And so with this, I put on waders and took the scanner out into the river, and we were able to do the condition assessment of the bridge. And we actually found that it was structurally deficient, and was able to take the data that we gathered during this condition assessment and document where the existing abutments were that were still fine, and helped lay out and engineer a new replacement bridge. So another case of using the same data that's gathered early on in a project throughout the whole project life cycle.
Hey Shane, it looks like we have another question here
Awesome.
from one of our good friends, Mr. Shields.
Okay.
The question is, do you ever see a need to scan areas under both hot and cold conditions in order to capture any variations caused by thermal expansion? I guess a great example of this would be this bridge.
Yeah, so scanning in hot and cold states is a very real thing, and we've experienced it more so in piping that has very large thermal gradations, to be able to measure the deflections and kind of expansion of piping. And you know, we can measure where, you know, if a spring can, is a spring can hanger working adequately? You know, is it doing what is expected out of it, by having those two different data points? So yes, Jason, that is great, great point. And you know, we can, with how quick it takes to scan, you know, we can gather that data and compare it relatively easily. Okay. A great example, speaking of thermal expansion, I was called in after a fire, and we were able to do the laser scans, and the room was probably 50 feet up to the bottom side of the roof girders, and would be very difficult to measure what kind of deflection we actually had in the girders themselves. So we were able to go in, laser scan it, and I took and calculated the theoretical deflections, you know, from the dead load and the live load of the structure, and then compared that with the observed deflections to then back calculate and get an approximate temperature of what the structure saw, to determine if the steel had any kind of issues beyond its permanent deformation. In this case, we were able to determine that the structure did not see, you know, a temperature that would cause permanent damage to the metallurgy of it. It did cause permanent deformation. We determined that permanent deformation that we saw was acceptable, and the structure was able to stay in service. Okay, just a couple more here. We were able to, another unique one is map out an underground void. So what we're looking at here is an old brick sewer, and see that the sewer had started to unzip and create a little sinkhole. Well, it wasn't very little, it was about 14 feet deep here. So on the left, we have a cross section of that void that we were able to map out. Then we continued the journey with laser scanning through multiple phases of the project. When they opened that project up to do the repairs to it, we found multiple underground pipes that were exposed. During the construction and exploration phases, we used the scanner to document the slope and elevation of those pipes, and quickly used FARO as-built to show those pipes relative to the new or the replacement manhole. So I've showed a lot of small things. We can also do very large projects. This here is a 86,000 square foot building footprint that we were hired to come in. It ended up being 990 scans, total of 3 people and 3 scanners on site for 3 days. And not only was it faster with greater accuracy, you know, versus doing this by hand, it would have probably taken 3 to 4 weeks with even more people to be able to gather that amount of data and collect that and bring that back to the office. You know, as you know, the introduction of human error is when you read the measurement wrong, when you write it down wrong, and then when you input it back into the computer. You know, so there's multiple touch points for human error here. Just a few more slides. I know I'm pushing up on my time here. So with that, we did the scans and then created a 3D model of that, and then kicked out ultimately, you know, 2D design drawings out of it. So we can provide and interpret that data in any kind of ultimate format that's needed for the project or for different stakeholders in the project. So in summary here, some of the high return on investment applications that we've found for laser scanning is the field measurements that we talked about, fewer people on site in the time of COVID. That's a very real thing of having few people on site. If we are unable to travel to the site in these times, we can coordinate with local scanning firms to be able to go on site, collect the data for us, and still provide engineering assistance. Demolition drawings are greatly see great benefits from it because you don't have to model what you're going to be taking out anyways. You can just show it right from the point cloud. Space planning, being able to take and create a region of an object and move it around in the space to help with that. Collision detection and virtual construction, as-built documentation at the end of a project, and a relatively new one to us is virtual reality visualization. So being able to interact inside of the model and the point cloud virtually. So those are a handful of things where we've seen the highest impact and cost savings to our clients with the use of 3D laser scanning. At this point, do we have any more questions?
Yeah, Shane, so if there's any other questions, please type them in now. We do have one right now. So since many engineering firms offer scanning as part of a project, how does Pearl Engineering differentiate itself from the pack long term?
I think that like I mentioned earlier, being able to just scan something is one thing, but be able to scan and interpret that data and have the expertise and baseline knowledge of how these industrial facilities go together and the history of these facilities, that right there is a great complement to be able to have what you as-built married with expertise.
Yeah, and Shane, I'm going to chime in on this one too. So there was a project that we had worked on replacing the process sewer at on that one project. Was actually, since we have been utilizing this technology for since 2015 or before, and a lot, buildings don't change much, your equipment changes, and one thing that's really nice is if we have already done a project in an area, we can typically utilize a lot of the previous scans. So it is I think a pretty good cost savings for our clients, and very useful information that we can go back and actually use scans that we might have taken a year or 2 years ago if they're still good, and mesh them over with the new scans that we've taken as well. So I know that we've done that a lot as well. So it's nice to have all that information already available, or we don't have to go back and redo scans too. So
absolutely. And talking of historic scan data is great for condition assessments of structures, because we can take old scans and new scans and overlay it and see if there's been any kind of change in deformation, or something that shows that there was an overload or some kind of failure to a structure.
Yeah, and we have another question from Jason, and the question is there a capability to mount the scanner to a drone to scan hard to access areas?
Yes, it is technically feasible. There's a company called Stormbee right now that takes and makes a drone, and they take the scanner just like ours and do that. I don't know that is commercially available. I think it's an expertise that they have. So there are firms and consultants out there that can do that and marry the LiDAR data with an aerial drone application.
All right, Shane, I don't see any questions at this time.
Well, I would like to thank everybody for joining us here today on this. If people who know me know that I'm rather passionate about laser scanning, and if you have any questions in the future, don't be afraid to reach out and ask, and I am happy to talk to anybody that'll listen about laser scanning.
Oh, it looks like we do have one last question from Mike Schill. How do you scan movable objects, overhead cranes, manipulate robots? How do you translate the device or rescan so you can simulate the different positions during post-process bases upon physical limits?
So that's a very good question. And typically what we've done is if we know that we're going to be interfacing with an object that's going to move, is we will strategically scan it at key points, kind of like in a stop motion stance. So we'll, gather it at either its extremes or something like that. And then we have those that we can bring together and kind of show the full range of motion of a piece of equipment or moving object.
Yeah, and that's another point where if there's a close contact too, that to make sure that we don't have clearance issues, that we can find that out from a cut plane view before you actually have to move a piece of equipment and verify clearances before, so there isn't an incident.
Okay.
Oh, it looks like we have another question. Oh, that's just a thank you. So you're very welcome, Mr. Shields. Everybody, I just want to say thank you for joining our second scanning webinar. Stay tuned on our LinkedIn. We'll and our emails and our blogs on our website. We'll have this available. So if you want to share it with anybody, that's great. Or if you just want to reference anything again, that's going to be on our website under our blog section, and we update that just about every other week now, and we've been very good about bringing that to you in a webinar once a month. So we also have our 3D, or we'll have some more 3D information coming up next month during our safety presentation with the Wisconsin Safety Council. We'll have a virtual booth, so look for us there as well. And that is everything. So thank you very much for joining, everybody. Have a great rest of your afternoon.
Bye now.